For today's notes, I'd like you to set up your paper similar to this. So one side for parallel, one side for perpendicular lines, and we're going to make notes on the symbols, what they look like, and key features. Here's an example of parallel lines and a set of perpendicular lines. We're going to start with the parallel lines. Parallel lines use the symbol of two vertical lines in between the letters representing each line. So L is parallel to M. You'll notice that in order for two lines to be parallel, they can never intersect. And the way this happens is if two lines have the same slope, so here the slope of 2, but they have different y-intercepts. My purple line has a y-intercept of positive 2. It crosses the y-axis here. And my green line has a y-intercept of 0. It crosses at the origin. Because they're always constantly going up the same amount and over the same amount, they will never intersect each other. Perpendicular lines are special because they meet at a 90-degree angle, so they form a right angle. Perpendicular lines are noted with an upside-down T symbol that kind of looks like a right angle. Perpendicular lines have slopes that are related, but are exact opposites of each other. So they're opposites because they are opposite signs. So one has to be negative and one has to be positive. In addition, they are also the reciprocal of one another. So 3 over 1, the reciprocal is just upside down, 1 over 3. So two properties there. The slopes are reciprocals, and the slopes have opposite signs. You'll notice that the y-intercepts are totally different, and honestly, they don't really matter much except for going through any particular point. So if you're trying to create perpendicular lines that go through a particular point, then the y-intercept might matter. But if you're just trying to show that they're perpendicular, you're just going to look at the slopes. In order to do this, we're going to have to review a little bit about how to calculate slope. Often in geometry, to make it a little more difficult and a little more challenging, we're not going to show you a picture like I just did. You need to be able to calculate and determine if the two lines are parallel, perpendicular, or neither, just from 2 points. Or in this case, you would need at least 3 points. So here we have an example. Our line goes through the point -5, -3, and the point 0, -1. You can see those marked on the graph. It was kind of difficult, actually, with this particular example to find 2 good points. I was looking for a point that goes exactly through the crosshatch of the grid, and I was tempted to use something like this at -3, -2, but you can kind of see how it passes by the corner and doesn't go right through the T. So be careful when you're choosing your points. Make sure that it really crosses exactly through that point. Next, I took the 2 points and I labeled them x1, y1, x2, y2. I do this so that I can use the slope formula. Now, I just did left and then right as my first point and my second point, but actually it doesn't matter which one's your first point and which one's your second point, as long as you're consistent. x1 and y1 have to be from the same point, and x2 and y2 have to be from the other point. Next, we just plug everything in. So y2 goes first, minus y1, x2 minus x1. So this is the change in y, which is like the vertical change, over the change in x, which is the horizontal change. So you might remember way back in the day, we called this rise over run. And change is always subtraction, so that's another way to remember it. Now, I have a minus here. And one of the most common errors when calculating slope is forgetting to write one of these two minus signs. So remember, the minus is part of the formula, and then the -3 comes after it. Subtracting a negative is kind of like the same thing as adding a positive. Less negative is more positive. So I'm going to change my calculations so that they reflect that, because that makes more sense in my brain. -1 plus 3 over 0 plus 5. I do my final simplified calculation and we get 2 over 5. Now, because we have the graph, we can go back and just double check. We should have a rise of 2 and a run of 5. If, for instance, you had the graph and you noticed that it was going up a lot and over just a little bit, we might check that we put the x's and the y's on the correct side of the fraction. So here, I go up 2 and over 5. Yep, that looks perfectly correct.